Hey gang, today we're going to continue our work with solving systems of equations. We're going to be looking at systems that have one, none, and infinite solutions. Determine whether each system has one, none, or infinite solutions by considering the following. Equations with one solution will cross only once. Equations with no solution will never cross. These are equations with the same slopes, which make the lines parallel. And equations with infinite solutions always cross. These are equations that are exactly the same. So here's our first example. Graph the following system. State whether each system has one, none, or infinite solutions and why. So here we have one where we have to start with y equals 6 minus or x minus 6. So we start at negative 6 on the y-axis, which is right here. And then we go up 1 over 1 since the slope is 1. Take your straight edge and neatly draw a line through those points. And remember, since we're drawing a system, we have to label it with its equation. Then we graph the second, y equals negative 3x plus 6. So now we start at positive 6 on the y-axis, way up here. And then since it's negative 3, we go down 3 and write 1, making our solution one solution because they cross once. Remember to label that equation and label the solution. So I'm going to circle it and put that it's at 3, negative 3. So this has one solution because it crosses once. Okay, so that should be simple, just like the ones we did yesterday. Let's take a look at another example. So here we have two equations. They look different, but let's see what happens when we graph them. Y equals negative 2x plus 3. We start at 3 on the y-axis because the y-intercept is 3, and then we go down 2 over 1 since the slope is negative 2, or up to left 1. Draw your line nice and neat. Use a straight edge, arrows on both ends. Label it with the equation. First equation is done. Then the second one says y equals negative 6 over 3x. So that does not have a y-intercept, so we start at 0. Then we go down 6 and over 3, or up 6 and left 3. Gives me those 3 points there. And if I draw my line nice and neat through them, right away you should notice that these two lines are not going to touch. And in the picture, they definitely look like they are parallel lines. And remember I said before, parallel lines are ones with the same slope. That's going to make our solution no solution. But in the equations, they don't really look like they have the same slope. But if we look closer, isn't 6 divided by 3 negative 2? So this equation could be negative 2x, which means they have the same slope, therefore are going to be parallel. So here we're going to write there is no solution because the lines are parallel. Okay, let's take a look at another example. Number 3. Again, we start by graphing the first equation, y equals 4/3 x. So we start at 0, and we go up 4, right 3, up 4, right 3, up 4, right 3, or down 4 and left 3, which isn't going to fit. So I'm going to take my straight edge and neatly draw my line through those points. Arrow on the end, label with the equation. Then the second equation, y equals negative 1/2 x plus 11. We start at 11, which I believe is right here. Let me count one more time. We are right. And then we go down 1, right 2, 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 or up 1, left 2. Take your straight edge, draw your line nice and neat through those points, arrows on both ends, and label it with the function rule. So here again, we have one solution, which is going to be 1, 2, 3, 4, 5, 6, 6, and 1, 2, 3, 4, 5, 6, 7, 8, 6, 8. So we could say again, there is one solution to this system. Since the lines cross only once. Okay, let's take a look at another example. Number 3. Oh, that's what I was just on, and it turned the page on me. So number 4, rather. Y equals 1/2 times 6x minus 8, and y equals 3x minus 4. So we have to distribute first in order to do this one. So this is equal to y equals 3x, because half of 6 is 3, and minus 4, because half of 8 is 4. But wait a second. Aren't these exactly the same? So right away, we should be able to say that this is going to have infinite solutions because the equations are exactly the same. And as a result, we only have to graph one of them. So we start at -4, and we go up 3 over 1, or down 3 and left 1, and draw our nice straight line through those points, arrows on both ends, and we're going to label it with both function rules to show that we understand that they are the same. Okay, so now you've seen all possibilities, one being when they cross once, none being when the lines are parallel, and infinite being when the lines are exactly the same. So you're going to try numbers 5 through 8 on your own. Please make sure you're checking in with me so I know that you've got it before starting today's exit questions.